Bismillahirrahmanirrahim. I'm Shahroz Ali. The topic I choose for this master's thesis is Education Conversation Solutions using Contact Center AI. Dr. Fruki Azam supervised this, and Dr. Aslan Shokat and Dr. Wasi Hyderabad is a GC member, and Dr. Mohammad Wasim Anwar is the external GC member of this master thesis. This is a presentation outline. The first one is introduction, second one is literature review, third one is proposed framework, and then implementation, validation, state of art comparison, and in the end, conclusion and future work. Production background. Chatbot is a conversation software system that is designed to emulate the communication capabilities of a human being then interact automatically with the user. Chatbots applications are classified into four groups. The first one is a service based, in which chatbots are designed to provide service to the customers. The second one is goal based, in which chatbots are designed to achieve some sort of goal based on the conversation history. Third one is knowledge base, in which chatbots are designed to retrieve something from the knowledge base or data sources. And the fourth one is response generated based chatbots, which are basically designed to generate a response on the runtime. Background. The focus of this research is on response generated based chatbot, which is actually the artificial intelligence approach, which is classified into rule-based chatbots. Second one is generative-based chatbot, and one is the info retrieval-based chatbots, and these are their implementation approaches. Motivation. This master thesis has three motivation. The first one is to get rid of titled system or education institution administrative start by automating the answer to a frequently asked question. Second one is provide an additional way that will created across multiple channels 24 by 7 to minimize leverage and intervention. And the third one is students do not have to pursue site searching for frequently asked question pages or on the other hand call the authoritative staff to pose inquiries. Goals and objectives. This master thesis has four objectives. The first one is to explore the purpose and application of chatbots in the education domain. Second one is to identify chatbots approaches that were currently used for the development of chatbots. And the third one is to identify the chatbot platform that were used for development of chatbots. And the fourth one is to design a chatbot named NUBOT to be a proof of concept aiming to assist international local students and NAS, which will be a good additional way for them to get information they are seeking. Literature review. From literature review, we are trying to answer these mentioned research questions. The first one is what is the purpose and application of chatbots in the educational domain. Second one is what is the most potential area in which there is a need of chatbots for future purposes. Third one is what are the chatbots approaches that were currently used for the development of chatbots. And the fourth one is what are the platforms that were used for development of chatbots. Research methodology. The protocol guidelines we adopted for systematic literature review are divided into four steps. The first one is the planning procedure, in which we specify the research questions and search and elimination criteria, and specification databases, specification search criteria, identification of search gap will be done. In the second step, we will conduct a procedure in which specification, searching keyword, section of criteria, data, and quality assurance criteria will be done. Third one is reporting procedure in which data section will then narrow down the potential area, analysis and interpretation of result will be done. This is the overview of our research in which we utilize the eight databases. From eight databases, we selected the 64 studies, and after high-level classification, we identify the five areas. The first one is teaching and learning. Second one is administrative. Third one is assessment. The fourth one is advisory, and the fifth one is research and development. Our focus over research administrative area, which is our potential area. So we further identify their implementation approaches of chatbot development in it, which is a rule-based approach. Second one is machine learning approach, and third one is deep learning approach. Then we further classify their implementation approaches in it, like pattern matching approach, AML approach, in the rule-based approach, and in machine learning approach we identify implementation approaches, supervised learning approach, and in deep learning approach we identify information retrieval-based approach and generative-based approach in it. Then we perform the qualitative quantitative analysis. From that we identify two chatbot platforms, which is the dialog flow platform, and the second one is the Rasa platform. And we also identify most commonly used languages like Python, AML language, which is artificial intelligence markup language that were used for the development of chatbots in the administrative areas of educational domain. And literature analysis result this is chatbots areas we identify in the educational domain with respect to their databases. The first one is teaching and learning, second one is administrative, third one is assessment, fourth one is advisory, and the fifth one is research and development. This is the pie chart which shows the chatbots weightage that were current and deployed in the educational domain, which includes teaching and learning 30%, administrative 90%, advisory 11%, assessment 14%, and research and development 26%. From literature view, we identified three implementation approaches that were used in the administrative area of educational domain. The first one is rule-based approach, in which chatbots were designed by searching a question from a pattern matching from defined rule in knowledge base. Second approach is machine learning approach, in which chatbots are basically designed to extract pattern from data and set over its tool through which instruction manually. Third approach we identify is the deep learning approach. These chatbots have the ability to learn from the representation of data itself, which is also known as a feature engineering approach that will also have the ability to identify data automatically to classify it. Literature review. Here I mentioned some approaches from the previously built chatbots that were used for in the administrative area of educational domain. The first study is develop the chatbot through the Dialogflow platform, which is a closed source platform, and it utilizes the deep learning approach in it, and also use the simple fallback classifier, and it has accuracy type issue and third participation issue. Second one, develop the chatbot through role-based approach, and it also has accuracy issues and domain specificity issues and data pre-processing required in it and fixed rule-based type issues. Third, we develop the chatbot through machine learning approach through a naive Bayes model, and it also has accuracy issues and domain specificity issues and data pre-processing required in it also. And the fourth one, develop the chatbot through deep learning approach and with the utilization of RASA platform, which is an open source platform, but they utilize the sequence tradition LSSTM model, and also use a simple fallback classifier, and it has no ability to recommend something, and it has also grammatical issues, accuracy type issues. So there is a need of a new chatbot framework in the administrative area of educational domain. The desired chatbot should overcome the above mentioned multiple issues in the previously built chatbot. For this, the development of chatbots, the first thing is the chatbot platform. For this purpose, we perform a chatbot platform selection criteria, which is also important as in respect to the accuracy wise of to generate better results. Based on the usability criteria, we distinguish the available platform in the market into seven different dimensions. The most important dimension is the domain source. As you can see that the above four chatbot platform are the closed source, and last one Rasa is the open source platform, and it also has the ability to easily integrate to the third party service and also outperform here as well. So we decided to go with a Rasa platform to that our which is also a open source platform, or our third party integration issue will be also sorted out, and we can easily deploy our chatbot on the Facebook Messenger, and we can also build custom web based UI as well. And the second thing is the chatbot approach, and the third thing is implementation approach, and the fourth thing is model technique. Chatbot approach, we will use the deep learning approach. Through that, our fixed rule based issue will be sorted out, and there is no data pre-processing required in it. And the implementation approach will be utilizes the hybrid model approach, which is a combination of information and retrieval based model and plus genetic based model. Through that, our accuracy issue will be sorted out, and model technique we will utilize is a BERT model, which is bidirectional encoded representation transformer, and plus DIT classifier, which is dual intent entity transformer, which is sort of transformer learning approach. Through that, our domain specificity issue will be sorted out, and we will utilize the dual fallback classifier, which is our custom made classifier. Through that, the desired chatbot will have ability of self learning, and it has will have also ability of recommend something, and during response generation or recommend something, our grammatical issue will be sorted out. There will be no error during response generation. Proposed framework. This is the NUBOT architecture diagram we are trying to build. For a training of model, there is a need of training data. For this purpose, for dataset preparation, we utilize the case study of NUS. Firstly, we list down the all question and then we prepare the answer according to it. Our main source of information FAQ that can be found on NUS website and administrative start of NUS. Primarily, the two modules spotted by will be spotted by our chatbot. The first one is accommodation, second one is admission. For dataset preparation, we to accelerate its cycle, we utilize the services dataset generator. There are we identify five dataset generator. The first four utilize a comparative linguistic structure for composing the layout. So we decided to go with a ChatGPT platform for two reasons. First thing is it's simple syntax to create a script, and its second one is Python library to support as well to integrate with RISA. Simulate data, then we categorize data into intent example based on the nest accommodation and animation module into the NLU file. As you can see that in the left side, we mentioned the five different intents, and then we refer it into domain.yml file for their response generation. Then action is created to determine the conversation flow in the domain.yml file with the prefix utter underscore along with the intent. These are the conversation and these are the responses with respect to the intents we created in the NUMD file. Then we create a conversation flow in the source.md file. This is the intent, this is the response, and their combination make a story. Then we passed the trend data to the NLU model where we made the NLP pipe. Through the parsing of NL text in the pre-processing step, we made a custom NLP pipeline which comprises of the BERT model, which is word embedding model, and it also contain a white space tokenizer to part text into tokens. Then Regex featureizer used to create a vector representation of user message. Then we use the lexical synthetic featureizer, which contain information of grammatical issues. And then CRF entity extractor we utilize to name entity recognition purposes. And then we made a custom profanity analyzer function in it to detect criminal word sensing purposes. And word counter featureizer also use in it to create a back of word representation of user message. And then we use the diet classifier in it for dual intent entity transformer purposes, and entity in synonym mapper is used to map synonym entity values to the same values. In the processing step of NLP pipeline, we utilize the policies of deep learning like memorization policies and TED policy, which is transfer embedding dialog policy to predict the response from the corresponding story with the confidence of 0 of 1. And then we make a two-step fallback policy, which is our custom fallback function to recommend the user based on the of the conversation history. Our chatbot also has the ability to interact with the database, which is MySQL for info retrieval based response generation. For the implementation purposes, we deploy our chatbot, our two distribution channels in the implementation part. Implementation GUI development. Rasa platform has also ability to easily integrate into third-party services like Facebook, and we can also integrate into web-based interface as well. This is integration structure. Firstly, we made a custom user interface using HTML, CSS, and JavaScript libraries, and the Flask API is called to route the home page. And this is our NUBOT custom web user interface. And then we also deploy it on Facebook Messenger as well, which allows the user of Facebook to interact with the chatbot as if were the normal user of the social network. Validation. Firstly, you evaluate the model, a huge customized dataset we made for this, which consists of 108 intent with 4263 examples. You can also see here. Then we perform data validation by dividing trained dataset into 80 by 20 splitting ratio using data split NLU command. The purpose of data validation to check there is no conflict into a NLU or store information in our domain.yml file. This is intent confusion matrix which we made through by running the rasa test command inside the CLI. Um, the vertical axis shows the true table and the horizontal shows the predictive table, and their point of intersection at the diagonal line shows that the true table correctly identified the predictive intents. This is intent prediction confidence distribution graph, which shows that every example being predicted with a confidence score of roughly 0.98 to 0.99%. This is our intent classification report, which shows that our model uh, correctly identified the intents with the accuracy rate of 99.64% with the precision of 98.557% and recall of 98.7% F1 score of 98.61%. Then we perform a testing. For this purpose, we made a test data set of 50 unseen questions that do not belong to the trained data set, and then we pass that data set to our trained model. Out of 47 question data set, 47 identified by our model. In the red highlighted questions, these are misclassified by our model. Out of 50, this is our data set. This is action confusion matrix. You can also clearly see that these three intents are misclassified by our model. Out of 50, we perform end-to-end level testing to test the 50 unseen data set. You can see that out of 50, 47 was correctly identified by our model, and we performed action level testing at the same time to test the whole data set, and we got the average accuracy of 96%. With the error rate of 4% and the precision 94.7% and the call in 96.0%, F1 score is 95.1%. Then we perform the state of art comparison. Check the credibility of our proposed methodology. We decided to compare the methodology with the state of art comparison. For this purpose, we got a dataset from the GitHub, and we tested the approach they mentioned in their uh, paper with our proposed methodology. The dataset they provided consists of 13 modules. You can also see in we loaded in the Rasa project. Dataset basically consists of 27,430 sample example, which is a huge dataset. Environment setup. The environment we provided the same we utilize for development of our chatbot. You can see that the same NLP pipeline as the backend we will use for this purpose, and same frontend we will use with the same programming language or version we will utilize for this experiment. And the author also provided the 121 text example in their data set. This is the action confusion matrix. The vertical axis show the true table and the horizontal table axis show the predictive tables. We perform the end-to-end level testing as well. Out of 121 example test set, our model identify the 78 example correctly, and we also perform the end-to-end action level testing at the same time to test the whole data set, and we got the accuracy of 76.2% with the error rate of 23.8%, and precision is 83.7%, and recall is 79.1%, and F1 score is 77.7%. And the result comparison. This table shows the comparison between the state-of-art chatbot and our proof of concept chatbot methodology. You can clearly say that Uh, in the the set of chatbot previously built with the dialog flow platform, which is a closest platform, shows the accuracy of 73.7% with a precision of 70.4%, and effort score is 73.9%, and recall is 77.9%. When we parse the same data set to our proposed methodology, its accuracy is also increased with 76.2%, and precision is 83.7%. F1 score is 77.7%, and recall of 79.11%. You can clearly see that our proposed approach is very encouraging results we got through it, and our results are far better than the existing state of chatbot. Conclusion and future work. Objective filaments. We utilize the hypermodal approach, which is combination of retrieval based neural network and general based neural network. Through that, our accuracy is also improved, and there will grammatical issue also sort out with the utilization of BERT model in generative based neural network approach. And we utilize the open source platform, and third party issues also sort out through it. And our chatbot has also ability to recommend something based on the previous history, and it can also have the ability to self learning. And a third party integration issue is also sort out through it. um, and we can also easily deploy it on the social media platform, or we can make any web interface integration through it. And we utilize a deep learning approach, um, and it sort out the issues of ML approach issues, which manual feature extraction issues, and rule-based approach issues as well. And it has a non-domain specificity, and which means that we can data-driven our proposed methodology through any data set, and can be applicable to any NL-based data set as well. Future work. The first thing we recommend in this is maintenance process. There is a need of an automated way in the future to easily update many questions, removing spot for new irrelevant question. And the second thing is the user thumbprint, and which is a additional feature which is useful for new board. This feature allow the chatbot to use the information letter in the conversation. And the third one is chatbot network. It is not easy to cover a large scope of topics, so there is a solution needed to create a chatbot per topic and organize them into a network. This is the demo of our new bot. This is currently you can see that info retrieval approach is done here, and this is recommendation based on the ambiguous input entered by the user, and self-learning ability also, and there is no grammatical issue during response generation on the runtime. This is a phase of Messenger UI. This is a desktop version. You can also use it through the Facebook Messenger UI or mobile version name. Question and answer.